Welcome, students, to today's session, our first chapter in chemistry, chemical reactions and equations. In your previous years, you have studied the difference between a chemical reaction and a physical reaction. Chemical reactions are where new substances are formed, and chemical reactions cannot be reverted to its original form by simple physical methods. So, in this particular chapter, we are going to study how to balance a chemical equation. Let us start the session with an activity burning of magnesium ribbon. Take the magnesium ribbon and use a sandpaper to remove the magnesium oxide deposited on it. Clean it up, you get a shiny strip of magnesium. Hold it with a pair of tongs, burn it using a spirit lamp or burner, collect the ash so formed in a washed glass. You have to take the precaution of keeping the magnesium ribbon away from your eyes. What happens? We get magnesium oxide. The equation is 2Mg plus O2 giving MgO. Let us look at another activity. Take a few zinc granules in a conical flask or test tube. Add little of dilute hydrochloric acid or sulfuric acid to it, as seen in the picture. Handle the acid with care. Always acids in the laboratories are to be handled with care. Observe what is happening to the zinc granules when acids are added to it. You will find that there is change in temperature of the conical flask. Let us now see from the above activities what are the observations seen by us. Along with the chemical reaction, there is change of state. There is change of color. There is evolution of gas. There is also change in temperature. These are the four parameters that can accompany a chemical reaction. That is, change in state, change in color, evolution of gas, change in temperature. Let us now look at what is a chemical equation. A chemical equation is a written representation of the process that occurs in a chemical reaction. A chemical equation is written with reactants on the left side of an arrow and products on the right side of the arrow. The head of the arrow typically points towards right or suggests that the chemical reaction is proceeding forward from reactant side to product side. These are some of the examples of equations. Zinc plus H2SO4, zinc plus sulfuric acid giving zinc sulfate plus hydrogen. Nitric acid plus calcium hydroxide giving calcium nitrate plus water. Barium chloride plus sulfuric acid giving barium sulfide plus hydrochloric acid. In addition to this, there are symbols of physical state. When an equation is written, liquid is represented by L, gas is represented by G, solid is represented by S, substance dissolved in water or aqueous is represented by AQ. Precipitate is represented by an arrow downward Evolution of gas is represented by an arrow upward. Now, how we are going to balance a chemical equation? Let us study the steps closely. Write down the given equation. For example, we are going to use this equation. C3H8 plus O2 gives H2O plus CO2. This is the equation that we are going to balance. Let us see how we can do this stepwise. After writing down the equation, what should we do now? Write down the number of atoms that you have on each side of the equation. Look at the subscripts next to each atom to find out the number of atoms present. These are the subscripts. What you have down below in the atom are called as the subscripts. So you will first look at the subscripts and write down how many atoms in total number you have on the left hand side and the right hand side. For example, carbon, there are 3 atoms of carbon on the left hand side, and on the right hand side you have got 1 atom of carbon. Next comes to hydrogen. There are 8 atoms of hydrogen on the left hand side and only 2 atoms of hydrogen on the right hand side. Next we will go to oxygen. There are 2 atoms of oxygen on the left hand side and 2 plus 1, 3 atoms of oxygen on the right hand side. So this is to be written neatly first. Let us see what we do now. We have to always remember that hydrogen and oxygen has to be always the balance at the last. This means that we have to balance carbon first. So we will take carbon to be balanced. We have 3 atoms on the left hand side and only 1 atom on the right hand side. Add a coefficient to the single carbon atom on the right hand side of the equation. Coefficient is that you will add a number to the front of the carbon. This place. When you write a number here in the front position of the carbon, it is called as a coefficient. We can never add any number below the atom. That is, we cannot add subscripts to the atom. Whatever number has to be added for balancing has to be written as the coefficient in front of the atom. So our equation is C3H8 plus O2 giving H2O plus 3CO2. In order to balance the 3 carbon on the left hand side, we are writing the number 3 on the right hand side. This is the coefficient. Number 3 is written on the right hand side. When we write this number 3, it balances the carbon atoms on both sides. But what has happened when you write 3 number in front of CO2? We have added 3 into 2, 6 atoms of oxygen to right hand side. Then our total number of oxygen becomes 7 on the right hand side. In a chemical equation, you can change the coefficients, but you should never alter the subscripts. Now we shall go for balancing the hydrogen atoms. We have 8 atoms on the left hand side, and so we are going to add 4 as the coefficient for water. 4 into 2 becomes 8, 8 of hydrogen. That way we balance 8 hydrogens on the left hand side and 8 hydrogens on the right hand side. The subscript can be multiplied with the coefficient to get the number. 4 into 2 is 8. Now we shall finish the balancing by balancing the oxygen atoms. We are having totally 3 into 2, 6 plus 4 oxygens on the right hand side. So we have to add a coefficient of 5 on the left hand side to make it 10 on both sides. This way all the atoms are getting balanced. Carbon is 3 and 3, hydrogen is 8 and 8, oxygen is 10 and 10. Our equation becomes C3H8 plus 5O2 giving 4H2O plus 3CO2, and hence we have completely balanced. This is the final form of the equation. C3H8 plus 5O2 gives 4H2O plus 3CO2. Hope you have understood the entire process of balancing. We can do some more examples, work out in your notebooks to find out how balancing is done efficiently.